Alright, welcome back. We are going now to look at the energy released. And we've been able to calculate it based on the equation given. Now, it's another form. What is the energy released? How do we calculate it? So you look at the question, the change in mass of fuel during a nuclear reaction is this. So this is the change. What is in kilogram? Just as we had in the previous class, we could calculate it in unit by atomic mass units when they give us the elements, subtract them. But yeah, they've already given us the change. It has to calculate the amount of energy released. Remember your Einstein's equation. So in physics, we always state parameters. So your change in your mass defect is 2 times 10 raised to power minus 27 kg. And your speed of light is 3 times 10 raised to power 8 meter per second. We are looking for the energy release. It is change in n c square. So that's 2 times 10 raised to power minus 27 times 3 times 10 raised to power 8 square. This is changing and this is c, speed of light, in square. Once you state your parameters correctly in physics, you can deal with any problem. When you multiply it, you're going to have 1.8 times 10 raised to power minus 10 joules. In this case, whatever you get now is going to be in joules, which you can still take it back to mega electron volts. Okay, now we have example 2. In nuclear reaction, the mass defect is this. So the energy release given the velocity of light as this. Of this is a constant. That is 3 times 10 raised to power 8 meter per second. But you notice that the mass defect here is in gram. You have to convert to kilogram. Please take note. Every time you convert from gram to kilogram, you are going to divide by 1000. That will give us 2 times 10 raised to power minus 9 kilogram. And then we use our Einstein's equation to solve. So that's change in n multiplied by the square of the speed of light. So we have 2 times 10 raised to power minus 9 times 3 times 10 raised to power 8 all square. So if you're going to punch the calculator, you're going to punch this guy 2 times 3 times 10 raised to power 8 times 3 times 10 raised to power 8 times 2 times this, or you punch 2 times this times open bracket like this 3 times 10 raised to power 8, close the bracket and put square. When you do that, you're going to get an answer which is 1.8 times 10 raised to power 8 joules. Very simple and very clear. So okay, now we have example 3. Material of mass 1.0 times 10 raised to power minus 3 kg undergoes a fission process which decreases its mass by 0.02%. Calculate the amount of energy. So the original mass of the material is this. This is the original mass of the material. 1 times 10 raised to power minus 3 kg. But there's a decrease in mass. And that decrease in mass will be the mass defect. So it's decreased by 0.02%. So it's going to be 0.02 over 100, that's percent, times that particular original mass. Because it's a decrease by this percent, so you need to find this percent now. What is this percent? This percent now gives you 2 times 10 raised to power minus 7 kg. So this decrease is called the mass defect. So that's why I wrote as change in n. And of course, your speed of light is 3 times 10 raised to power 8 meter per second. So if you're going to find the energy released, it's going to be change in n times c square. That's going to give us this 2 times 10 raised to power minus 7 times 3 times 10 raised to power 8. That gives us a wonderful answer, 1.8 times 10 raised to power 10 joules. So I think these examples enough for you to understand how to calculate energy release. I've showed you on the other aspect where giving unified atomic mass unit. Now this other aspect also I showed you. In our next class, push further to other aspect of nuclear energy and radioactivity. Thank you.